right, hello everyone. My name is Dr. Chelle. Thank you for coming to Dr. Test Prep, and thank you for caring about you to do the best that you can on the PSAT and SAT, which is what my series right now is about. You should have paper and pencil, or you should have my book. We are on page 75. You should have your Desmos calculator open. Hopefully you've split your screen, and make sure that when you click the link in the description to Desmos that you have gone to College Board. We are doing Khan Academy Unit 4 Lesson 10, and I've written some basic questions that kind of mirror what the basic examples are on Khan. All right, question 1. The equation that represents the growth of a high school can be expressed as. Now, this is what I tell my students. Anytime that they see an equation, stop reading and type the equation into Desmos. The reason is sometimes things make so much more sense when you have a picture. Now, clearly right here, I don't see a picture. So what I'm going to have you do is I'm going to have you click this gear or wrench, and we're going to change my Y values to 5, let's say 520. And the reason is, if you remember with exponential functions, the first number is the initial value. So we're going to do 520. Why am I putting it there? We're going to make this say 520. And now we can see like the graph makes sense. Okay. And then, yeah, we can even just do that. All right. So here's our picture. So the equation represents, X represents years, and Y represents the number of students. So truthfully, everything on the left side of the Y-axis doesn't count. So I'm going to kind of just scroll this baby over. The reason why it doesn't count is like we can't have negative years. Okay, so this is the graph we're looking at. So what does the 1.1 stand for? So this was, you didn't need to type it in, but it's still important to look. So we know that we have growth. It tells you that X represents years. So it's not this. Y represents how many people are at the school. So it's not this one. So we're either at the initial population or the growth rate. The generic formula for exponential functions is this, or exponential equations. A is our initial population. So in this case, it's 500, and B is our rate. Okay. And in this case, it's growing. So the answer is choice B. Robin's purchased, why did I put that? Robin purchased a car after graduating college for $25,000. Her car depreciates 12% every year. What is the value of her car after 5 years? I love this question because it's ridiculously easy. We're going to close this out, and we're going to click the home button to come back. We'll end up having to change the settings again anyway. But, oh, actually, we won't for this one. We're going to put f of x. If they gave you y equals, you would need to rewrite it as f of x. We have $25,000 was the initial car, 1 minus 0.12, and shift to the x. Okay, so I could use my settings and turn my y-axis all the way up to like 26,000 to see the graph. Okay. But the easier way to do this is just write f of 5. And it gives you the answer, letter A. A small town is slowly growing at a rate of 2% per year. The growth can be modeled by the function below. What is the population after 3 years? So we're going to put it in here. 5,000 times 1.02. And then we'll put the t. Okay, so we can see it right here. It wants 3 years, so you could type in like t equals 3. Yeah, I didn't think it would happen. The easiest way to do this is just doing p of 3. Now, sometimes I have found that it's better to change like the t's to x's, but for our purposes, we'll just leave it like this. And the answer is 5,306. but 0.04, but we know we can't have 0.04 of a person. So 5,306 is the best answer. If you thought these were easy, they were. Come back in our next video where we're going to do some more harder examples. Thank you so much for watching. Bye, guys.